Good morning. This is Monday, January 31st. Hey, we're already for January in 2022. Wow. Okay. This is our warm-up. We are writing the equation that goes with the table below. We did a quick refresh in my class. I always say the email. The equation that we use is y equals mx plus b, and we talked about that last week, where the m is our rate of change or our slope, and then the b is our y-intercept. Okay, we made it spicy because we're KAP students. So pause and play when you're ready to try. All right, so this in red is what we have to guess. Okay, so whenever I find my rate of change, to find the rate of change, how do we do that again? It's the change in. Very good. Okay, so let's find that change in y over x. Uh-oh, Miss Lyle, what's she doing to us? What's happening?
Fraction.
Fraction. And to find the change in fractions, what else has to happen? I need a common denominator. So I can't get this down to 2, but I can get this up to fourths. So how many fourths is 13 halves? So same thing as 26. Okay, to find that change, we just add or subtract. So how did they go from 23 to 26?
They add 3/4.
Added 3/4. Do we agree with that, class? Okay, did it continue on? 6 plus 3 gives me 29. Yeah, okay. And then the change in x was plus 1. So if I put that change in y, 3/4 over 1, what does that just simplify down to? Anything over 1 simplifies down to itself. Okay? Are we good with that? Was Miss Lytle evil and spicy, crazy?
Yes.
Who I am as a person. You're welcome. Happy Monday morning. Hope y'all are ready. All right, so that is my multiplier, so I can plug that in. The y equals 3/4 x. And then what I can do is I can plug in a number and see what I get out. What numbers do y'all want to plug in? 4. Honestly, I get it because it's like, I like pretty numbers. Me too. Okay, I'm going to plug in a pretty number and see if I get a pretty number. So we're going to do y equals 3/4 times 4, and then see what we need to add or subtract. Some of y'all might be able to do this in your head, but let's just review how to multiply fractions by a whole number. How do we do that?
You put 4 over 1.
Very good. And then just multiply like normal. Okay, so class, what's 3 times 4?
12.
And 4 times 1? 4. And 12 over 4 simplifies down to 3. So I put in 3, but I need to get what value out? I need to get out an 8. So I still need to add 5. Okay, so that equation is 3/4 x plus 5. Do not let the fractions scare you. They're not that bad. You could also turn it all into decimals. Just not getting it. Okay. What questions or clarifications can I make on that? Are we good? Has it settled? Yes.
So, instead of making a common denominator, there's no one.
Yeah, if you did want to find a common denominator, you could have turned them, honestly, both into decimals. It just takes extra steps, in my opinion. But if I turn fractions into decimals, do y'all remember how to do that?
Top and bottom.
Top in, bottom out, very good. 23 divided by 4, so that goes in 5 times. Gives me 20, I'm left with 3. Decimal, 0, 0. Goes in 7, 28, 2, 0, 5. And you get this is 5.75. And then I would honestly be in my head and say this is the same as 6 1/2. And 6 1/2 is what decimal class? 6.5. And then you can find your difference that way. You can do 6.5 minus 5.75. Because it's decimals, I would need to add in that 0 and then subtract 10, 14, and 5. 10 minus 5 is 5, 14 minus 7, and 0.75. That change of 3/4 is the same thing as the decimal of 0.75. Okay, I think it's extra math. I'm not scared of fractions. I do not let them just cheat me. I like strong movement. Okay? Is that okay? Do we accept it? Sort of. Michael says that.
Do you like fractions?
I don't mind them. Sometimes they're better than decimals, believe it or not. Decimals can get scary too. They can. All right. Let us go ahead. So this is on the back of your note packet for today. So flip to the back, and I want to see what you can fill in yourself. Now, please don't go and circle A, B, C, or D. You're doing it for all of them. I want you to take a few minutes. I'm going to set a timer for 3, and I want you to say whether or not it's multiplicative. We've talked about that. We haven't talked about proportional, but see if you can maybe take a guess. I would do this in pencil because, again, I haven't really taught you, well, I've taught you some of it, but do it in pencil. That way we can go make any changes. But basically, again, you're going to say proportional or not, equal, take a guess. Multiplicative or not, and then see if you can write your equation. Okay? Pause and play, and you've had some time to look through it. All right. So let's start with the multiplicative column, because that's one that we should be really, really familiar with. When we talk about multiplicative, what do we remember about that stuff? Multiplicative. Starts from the origin. What else? Yep. Linear. How are they going from X to Y? They are multiplying. Very good. Okay, so just by that, let's see what, I'm going to go one by one and y'all tell me yes or no. For A, do y'all say yes or no? Yes. Go through the origin and they're multiplying by 3 each time. Great. For the second one, no. Automatically I can say no because it's not 0, 0. Or you can put an X if you want to do that. For C, no, because it doesn't go through the origin. Y'all can say it a little prouder. For D, yes. What is it multiplying by? 5.5. Y'all agree with that? Let's do 4 times 5.5. Okay, go through the origin, but that doesn't mean it's multiplicative. They might have put just some random words in there or some random numbers. That's 20, 22. Yep, that works out. Okay, so yes, it is multiplicative. Can we multiply by decimals? Yes, of course we can because we're big kids. Okay, and then the next one, multiplicative. Yes, what are they multiplying each time? Times -2. Very good. All right, so let's see if we can, we already sort of wrote some of the equations for those. So for A, we said that y is equal to 3x. Do I need to add or subtract anything? No. Okay, that's the whole point of being multiplicative is you don't have to do anything extra. When it's the combination of the two, that's not multiplicative. B, what is the equation on B? What is the equation on B? It's not multiplicative, but there's still an equation that goes with it. What do y'all see? How are they going from X to Y? Maria. What are they plussing to? I want the whole equation. Y equals X plus 2. Very good. An equation isn't just plus 2. It's the whole thing. For C, what do y'all see happening? Okay, let's come back to C, because that's not just multiplicative or just opposite. Okay, for D, what is it? We said y is equal to 5.5x, and for E, we said that was going to be y equals -2x. Very good. Okay, so going back to C, again, it's not just adding, like, because if I look at it, I would be like, oh, it doesn't go through the origin, plus 3. But does plus 3 work for the second one? 1 plus 3, does that get me back? No. Okay, so it's not additive, it's not multiplicative, it's a combination of the two. So remember how we do that. We first find that rate of change. So the change in y, how did it go from 3 to 5? Plus 2. How did they go from 5 to 7? Plus 2. What did they do? Plus 2, plus 2. Okay, what are they doing to the x value? Plus 1. What did they do? Real wait.
Can't see.
Well, it's on your paper. Okay, plus 1, plus 1. So my rate of change in this is the change in y over the change in x. That would be 2 over 1, which simplifies down to class 2. Okay, so that y is equal to 2x. But does that work for this input and output? No. What do I still need to add or subtract? Plus 3. And a good hint is my y-intercept is plus 3. Okay, so I'm going to fill that in. Y equals 2x plus 3. So again, this shows us a few things. Again, when it's a multi-step, it is not multiplicative. It's neither additive nor multiplicative. It's just a slope intercept. Okay? Are we good with that so far? Okay? Now going back to proportional. Now we haven't talked about proportional when it comes to equations, but have we talked about proportional before? Yeah. Okay? And when we do proportions like normally, okay, a proportion, when you have like two fractions, and what do? Like if I had 4/8, what's something that's proportional to 4/8? 1/2. Okay, because what do you do to both? Divide by 4. Divide by 4. I can also say that 16 32 is proportional because I times by 4. Okay, when it's proportional, it's doing the same thing to the x and the y. Do we remember that from proportions? Okay, so let's go see if we can apply that to our problem here. So I never look at the origin because zeros are weird. Okay, zeros just don't really help us too much unless we're finding the y-intercept. But let's look at this. Let's see how we can talk about this. When I look at proportional, give me a second. All right, so what it is, to check if a equation is proportional, is we pick a pair of points, okay? So I'm going to do like 1/3. And I'm going to put y over x. What is my y value in this case? 3/1, and that just applies to 3. I'm going to see if I get that same ratio every single time. So if I do that this point, if I put y over x, 9/3, is it the same? Yes, okay? So that's how we tell if something is proportional. Honestly, what I'm going to do is we're going to go teach the lesson, and then we're going to come back and just tie it all together about whether things are proportional or not. Okay? So again, we're going to come back, we're going to put a pause on this, we're going to teach the lesson, then we'll come back to that problem. Okay? So we are going to be talking about what it means to be proportional and having a constant of proportionality. Everyone say the word proportionality. Proportionality is a different way of saying proportional. Okay? So two quantities are going to be proportional if they have a constant ratio or a unit rate. Okay? It's going at a constant rate every time. For two quantities, when the ratio is not constant, if something is not constant, then we would say it's not proportional or non-proportional. Okay? Now, there's quicker ways to tell when we're looking at like graphs and tables and stuff like that. Another way we can determine if two quantities are proportional is to graph them on the coordinate plane. It says that if the graph of the two quantities is linear, meaning what? What does it mean if it's linear? It's a straight line and it passes through, take a guess, the origin. If it's linear and passes through the origin, then the two quantities are proportional. What other kind of relationships have we talked about that are linear and go through the origin? Multiplicative. So basically, if something is multiplicative, it's going to be proportional. If it's not multiplicative, it's not going to be proportional. Here, that's the lesson, basically. Okay? This also means that the two quantities have a multiplicative relationship. The measurement of how two quantities are proportional, so what we call the constant of proportionality, is just that multiplier. So the measurement of how two quantities are called the constant of proportionality. Okay? And here we go with algebra. They use a letter to represent it, the constant of proportionality. And it changes sometimes, but on your star chart, they're going to use the letter K to represent your constant of proportionality. But again, it's just whatever your multiplier is. When I talk about that constant of proportionality, the way that I calculate it is the ratio of y to x. That's an awful x. Okay. Again, since it's a ratio, I can write it as a fraction. When I write it as a fraction, it's going to be y over x. And again, that is my multiplier. So when I plug that into my equation, I'm only looking at multiplicative relationships. So it would be in the form of y equals kx. It's not going to have anything to add on. It's just the multiplier. Okay. Just some things to fill in. This is just side notes. You might notice this or not. The x, if you haven't already noticed, the x is always the denominator. Like when we put change in y over change in x or y over x. It's because we don't really, like the x is our independent value. That's what we're changing. We're looking at the top number. We're looking at that y variable because it's what's changing in relation to what we change. Okay, we always measure the dependent value, aka our y, based on the independent value. So y, or our independent, is always the base for the bottom. Okay, that's just some side information, not super duper trivial. Okay. So we're just going to practice finding the constant of proportionality. We're going to do it from tables, we're going to do it from graphs, and then we'll do it from equations as well. It's super quick and easy to check. Okay? How do we do it? We find the ratio of k for all points. Okay? We do it for all points except for one. There's one that we never look at because it's always weird, and Mr. Lytle has already said which one do we never look at? For the 0, okay? We do not make a ratio when x equals 0 because zeros are special little potatoes. They have to have it their way. Okay, if the ratios are all equal, then it has a constant of proportionality. So again, y is equal to, k is equal to y over x. So let's find some. We never look at 0, 0. But let's find our relationships. If I put y over x, for the first one, 3 over 1 simplifies down to 3. 6 over 2, for that second point, I'm putting the y value over the x value. What does that simplify down to? 3. If I put 9 over 3, that simplifies down to 12 over 4. Is it all simplifying to the same thing? Does it have a constant of proportionality? Yes. Okay, it is proportional, and that k value, that multiplier is 3. Okay, do the next one. All right, what do y'all say, yes or no?
Yes.
Yes. Okay, if I put negative 3 over 1, that simplifies down to negative 3. If I put negative 12 over 4, that simplifies down to negative 3. So it is proportional, and that constant of proportionality, aka that multiplier, is negative 3. Looking at the next one, what do we think? Not proportional. There's a couple reasons. Why? For what? It's additive, okay, because we can see that it's additive. I can see also that simplify it's not the same. There's one more reason. It doesn't have 0, 0. So that's the key, is it doesn't have 0, 0, but let's also look at the other relationships. Again, if I was trying to calculate it, y over x, if I pick any point, let's do that first one. Y over x 4 over 1 simplifies down to 4. But for it to be constant, it has to stay the same all the time. If I pick a different one, if I put 6 over 3, that simplifies down to 2. Are 4 and 2 the same number? No. So it is not proportional. There is no constant of proportionality. Okay? They do not simplify to the same thing. So when it is non-proportional, there is no constant of proportionality. I'm going to abbreviate to the KAP Constant of Proportionality. Remember the rock and the KAP? Some people call the rock the croc because it's the constant rate of change. So it's a croc. Let's go with it. Yes.
This math has such long words.
This math has such what?
Long words.
Well, that's why we shortened it. You're okay. All right, that's from a table. Let's look at it from a graph. Okay, it's really easy because you just need to check 2 things. There's 2 things. Check if the graph is. What did we say earlier? We check if the line is linear and passes through the origin. It should be fairly simple because y'all are rock stars at this. Okay? If it's linear and passes through the origin, check. It's proportional. Woo! Okay? And then just to find the constant of proportionality, you put y over x in simplest form for any and all points, except for, what points do we never use? Minus and not origin. Again, y'all have said that quite a few times. So example 1, does it go through the origin? Example number 1, does it go through the origin? Is it linear?
Yeah.
Proportional. Number 2, is it going through the origin? Is it? Yes, it's going through the origin. Is it going through the origin? Yeah, but is it linear? No, bye-bye. Not proportional. Okay. Third one, linear?
No.
It's linear.
It is.
What I'm at. That's a line. It's linear,
Yeah.
but does it go through the origin? No.
It does not.
I'm just testing you. I'm changing it. Okay. Does it go through the origin? Is it linear?
Yeah.
Okay. So we're gonna go find K, but on these 2, I'm gonna say not linear. That's why we said no. And this is not through the origin. Not through origin. Okay. Let's find K. Okay. Again, K is the ratio of any y to x value. So I'm going to use just this point right here. What is the ordered pair for that point?
2, 1.
I disagree.
1, 2.
1, comma 2. To find the rate of change, I put y over x, so I'm going to put
2 over 1.
and that simplifies to
2.
bam. Do the next one. The last one. I mean. Find the constant of proportionality. Okay, what did y'all get? Back table, what are you boys? What did y'all get? Well, no, on this one. A, what did you get? Do y'all agree, class? It is -1. Yeah, I felt like you weren't listening. So this one right here, that's a point. The ordered pair is 2, comma -2. So if I put -2 over 2, that's just -1. Now, again, the reason why we don't use the origin, it does have to pass through the origin, but the reason why we don't use it when we're finding that constant of proportionality is because it wouldn't fit in with the rest of them. Okay, so if I put 0 over 0, well, we'll learn this later in life, but that's actually not even a number. If you put 0 divided by 0 into any calculator, it will pop up and say error or undefined or does not compute. Okay, y'all really want to try me, y'all can, but it just doesn't exist. Okay, because it just doesn't work. So it does have to pass through the origin to be a proportional relationship, but you can't use it to calculate it because, yeah, did it work? Does it say error or undefined? I know, it's like I taught it before. Wow. All right. And lastly, from equations. Again, super easy. Super easy. A proportional equation must be in the form. What kind of relationships do we say are always going to be proportional? It's always going to be multiplicative. If it's not multiplicative, it's not constant. Okay? So it's always going to be in the form of y equals kx or mx or whatever you want to say because it is multiplicative. Notice how the Bible always sounds like her words. She is a kindergartner. Okay? K is that multiplier. Again, I've used this other word, coefficient, a few times. Coefficient. I can't ever spell it. C-O-E-F-F-I-C-I-E-N-T. Coefficient. It's just another word for the multiplier. Just like in the real world, there's a lot of synonyms, a lot of words that mean the same thing. It's another word that means the same thing. Okay, so let's just go through proportional not. For the first one, proportional not.
Yes.
Yes, because it's multiplicative. What is that constant of proportionality? It's my multiplier, so it's just 10. You'll see how I did that? Okay, try the rest. Ready, go. What? All right. Proportional or not?
Yes.
Yes, my constant of proportionality. 3.2. Next one. No, because because it has that plus 4. Nothing. Okay. Next one. Yes, and it's just 5/3. It can be a fraction. That next one. No, I don't even know what that means. That's too spicy. And then lastly, yes, and it's -9. Very good. Now, an important thing that we're going to have to keep in our minds, okay? This is where things start to cross wires, and you just have to be careful. How are constant rate of change and constant proportionality different? The constant rate of change is measured, it's a change. We're looking in the change of y to the change of x. Okay, we're finding that difference between 2 points. With the constant of proportionality, I'm just looking at a point. I don't have to find a change in anything. It's just the ratio of y to x. Again, with the rate of change, I'm looking at change. Constant proportionality, I'm not. Okay? Rate of change, it can happen in additive. It can happen in multiplicative. A constant rate of change is in any linear relationship. Versus the constant of proportionality only happens in what kind? Multiplicative. Okay. This is something we'll practice back and forth a lot for the next like 3 days and stuff like that. But just make sure you're actively keeping those things different. For my class, we're going to do a quizzes or homework. I'll give y'all like 2 attempts, and I'll take the highest of the 2. Please get that code from your teacher. Thank you, guys.